going to be multiplying binomials. Now, guys, in the next chapter, we will be doing this backwards. It's called factoring. It's one of the major things that you're supposed to know when you come out of Algebra 1. So if you can master it going forward, then usually going backwards is much easier in the next test. So, when you are multiplying binomials, you are multiplying two binomials together. They're going to be inside parentheses like this. And you're going to be using a method called FOIL. It stands for first, outer, inner, last. We're going to be drawing on our pictures, creating what some teachers call the wave, the crab claw, whatever you want to call it. When you multiply a binomial times a binomial, it looks kind of 2D. And when you do a binomial times a trinomial where you have three terms, it kind of turns it into a 3D picture. You'll see what I mean when we do this. To multiply the first two, we're going to draw a line that connects the x to the x. Okay, when you draw that line, that's going to be distributive property multiplying across here. Notice, guys, there's no plus or minus in the middle. This is multiplication. This is right next to each other. It's the only time you do this. This is not combining like terms. This is multiplying. So when I multiply x times x, guys, this is the thing I told you it was the big deal to know from the very beginning of the year. What's x times x? X squared. And then outer 2 is going to be x times 5. What is x times 5? 5x. Then the inner 2 right here, you're going to multiply the 2 times the x, which is just going to give you 2x. And then finally the last is going to be the 2 times the 5, which is going to be plus 10. See the little like wave? It looks like the Ocean Spray ad, like little logo. Kind of. I mean, like I've never drank Ocean Spray in my life. It's just, call it crab claw, wave, whatever you want to call it, it's boiling, guys. Now, why can't this be my answer? It's not simplified, it's got like terms. I've got to combine like terms, and I'm also going to put it in what's called standard form. We're going from the highest power down to the lowest power, which is x squared plus 7x plus 10. And that would be my final answer. Huh? You're good. Anybody have any questions, concerns, anything about it? Guys, this is it. This is the only topic we do today. Being able to do this and do this very well and know the difference between this and when you add and subtract is huge. Because next we're going to be combining them. You got to know how to add and subtract and multiply and divide. Okay, here we go. So for the next one, still have just variables in front, still have just numbers at the back. Some have plus minus, some have plus plus, some have minus minus. You're going to have every little combination, so be careful with your signs. We're going to start by multiplying y times y, which is y squared. Then we're going to multiply y times negative 4, which is going to be negative 4y. The next thing we're going to do is multiply the 8 times the y, which is going to be plus 8y. And the last thing we're going to do is multiply the 8 times the negative. Now guys, be careful. It's 8 times negative 4. What do you write it as? Minus 32 or negative 32. You can say it either way. Absolutely. Does anybody have any concerns, questions, anything so far? Just on the setup. Guys, we just got done with distributive properties, so this should not be that unusual. We are going to combine our like terms in the middle and simplify it till we get our answer in standard form, which is y squared plus what? 4y is correct. Minus 32, and that would be your final answer. You cannot combine anything else because the rest of them are not like terms. Notice I did not change the exponent on the variable when I added my like terms. You have to know the difference between adding and subtracting and multiplying and dividing. Okay, here we go. Z times Z is going to give me Z squared. Notice I might write my 2's with a loop in them because my Z's and 2's look a lot alike. My Z times negative 12 is going to give me minus 12Z. Negative 6 times Z is going to be negative 6Z. And then guys, what's the last part?
72.
We don't just write 72. What do we write?
Positive.
positive plus, however you want to say it. Be careful. You got to know that it is a plus 72 because a negative times a negative is a positive. Then when we combine those two in the middle, guys, when you're adding negative 6 and negative 12, negative 6 and negative 12 come together to give you negative 18z in the middle of that problem once you simplify it. Okay. Now, notice every single one of these has turned into a quadratic binomial. Quadratic binomial. We're going to be factoring these a lot in the next chapter. So being able to do this going forward is going to help you go backwards. In the next chapter, this is going to be the problem, and you're going to be going to this as an answer. It's basically the same thing going backwards. Okay. Yes, ma'am. Yes, it always goes from the highest power down to the lowest power. Yep. Anybody else? And if it's not, you need to rearrange it. That's a good question. Okay. Here. What I saw here. Okay. Here we go. So for the next one, guys, what's different about this one? Yeah, there's numbers in front of those variables. It's going to have a coefficient. I heard the word. Guys, absolutely. 5x times 2x is going to be 10. You multiply the 5 times 2 just like always. And then x times x is x squared. Then we multiply 5x times 7. 5x times 7 is going to put you at 35x. Then it's going to be negative 4 times 2x. Negative 4 times 2x is going to be negative 8x. And finally, negative 4 times 7 is going to give us negative 28. Okay. Now, when you combine those two in the middle, guys, what is that going to give you when you combine those in the middle? What was it?
27.
Excuse me, 27x. There we go. Fine. Anybody have anything they're having an issue with so far? Concern about? Question about? Anything before we move on? Okay, so my next two are going to be a binomial times a trinomial, guys. Can you see the difference in the next problem and the ones that you've been doing? This time, instead of having 2 terms and 2 terms, you now have 2 terms and 3 terms. Now, I'm going to go back before we move on. Guys, what is 2 times 2? 4. Look how many terms you got. 4. See that? So, if I have 2 and 3, how many terms do you think you might get? 6. 2 times 3 is 6, because you got to distribute to each one. So 2 times 3 means I should get 6 terms. Is my answer going to have 6 terms? Not necessarily, because you might combine like terms. Probably will. Most of them start with 6 and move down to 4. Can they move down to less? Yes. Can they stay at 6? Yes. But the most common way you'll see it is you'll start with 6 and you will end up with 4 as your answer when you're multiplying a binomial times a trinomial. Here's what it looks like, guys. We're going to multiply 3a times a to the second. That's going to give us 3a to the, guys, what is the power on the a? When I multiply them, what would that be? 3, because there's 1 here and 2 here, which is a total of 3. And when you multiply like bases, you add their exponents. When you multiply like bases, you add their exponents, guys. Okay, here we go. 3a times negative 12a is going to be negative 36 a to the what? Second. Because 1 and 1 is a total of 2. And then we multiply, guys, when you multiply anything times 1, 3a times 1 is just going to be 3a. Okay. We took care of everything with distributing the 3a. Now we need to go through and distribute the 4 to everything. So here we go. 4 gets multiplied times each one of the things that's back here. So it kind of turns into like a 3D crab claw when you do it like that. So here we go. 4 times a squared is going to be 4a squared. 4 times negative 12a is going to be negative 48a. 4 times 1 is going to be 4, because guys, anything times 1 is that number, so 4 times 1 is 4. Okay, now you look for the combining like terms. Just up till there, does anybody have any questions before I start looking for like terms? Okay, here is an a squared, and here is another a squared. Here is a 3a, here is another a, negative 48a. Okay, you go from the highest power down to the lowest. Since there's nothing to combine with this, you write it out in front. The 3a to the third power goes out in front, does not change, does not do anything. Because these both have a square on them, you're going to use your calculator and find out what is negative 36 and positive 4. It's negative, isn't it? Negative 32, a to the second. You never change the exponent when you add and subtract like terms. I keep saying it. For the next one, you're going to combine the a and the a. When you combine 3 and negative 48, it's going to give you negative 40, that's not a 4, negative 45a. And then guys, since this doesn't have anything to combine with and it's a constant, it's going to go on the end. All you do is write plus 4 on the end of the problem and you're done. Anybody see anything they need to ask about? Concerns? Anything about it? Okay, guys. What form is it in? What do we call that? Standard form. And, oh, there's Alana. Sorry, she's sending me the question. Okay, so, guys, what would you call it? Ooh, what would you call it? A what? A cubic polynomial is correct. I had to be careful how I said it. Cubic polynomial is correct. The highest power is 3. There are 4 separate terms. There's no special name once you get past 3, so it is a cubic polynomial. Nice enough. Okay, guys, here we go. Last one. Here we go. Oh, now listen, guys, do y'all see that I switched them? I did this on purpose. You see how the binomial is second? Now, watch. Don't write this. Don't write down what I'm writing down. Okay? I'm actually going to copy it down here just so you can see it really clearly because I want you to see something about this and I want to make your life easier. So, here we go. Okay, guys, if I try to multiply these and I go from here and I say multiply to here, multiply to this one, and then I go multiply to here and then multiply to this one, where am I going to put the lines for the 9? It's going to get complicated. Then it's going to be like on top of each other. I'm going to have to cross lines. Don't do that. Now, if you have a trinomial times a trinomial, there's nothing you can do. They're going to cross each other because you don't have more than a top and a bottom. There's only 2 spots. But if you have a binomial and a trinomial, always draw your lines from the one that is a binomial. Watch. If I multiply it here, here, and here, those can all go on top, and then these can all go on the bottom to connect them. There you go. Now, it doesn't matter which lines go on top and which lines go on bottom. It doesn't make any difference, just as long as you know how to get them across so that you multiply them correctly. I suggest you multiply to the highest power first because that'll keep them more in order down here. It's not required though. So 3b times 2b squared would be 6b to the third. 3b times 7b would be 21b squared. 3b times 9 would give us 27b. And then guys, think about this. When you multiply something by -1, what happens to it? It just changes. It doesn't change necessarily to a negative, but it changes to the opposite of what it was. Since these are all positive, they are going to turn into negative. But if they were negative, they would turn into positive. They're just going to change signs. So -1 times 2b squared is going to be minus 2b squared. Negative 1 times 7b is going to be minus 7b. And negative 1 times 9 is going to be minus 9. I'm going to highlight the like terms so you can start thinking about combining those. Okay, here we go. So, since the 6a to the third power does, 6b to the third power does not have anything to combine with, you're going to list it out in front. It's going to be your first term. Since the green ones, the b squareds, are like terms, you're going to do 21 minus 2. That's going to put you at 19b squared. You do not change the exponent when you add and subtract like terms. Then you're going to combine the 27b and the negative 7b. 20 minus 7 is going to give you 20b. And since the 9 is a constant on the end and doesn't have anything to combine with, you just write it on the end, and you again have a cubic polynomial. Okay, guys, any questions, concerns, anything about it? Wonderful. Let's get you